Welcome back to the lab. As promised, here's the video about me trying to get this 6-line self-scan display to operate. We'll see if we can fire it up, get some pixels on there, and maybe write a text message if I can get that far. So this is the same one in the hamfest hall, obviously. It's got the display glass, and then the display driver board, and then this big old honkin' Fairchild F8 based CPU board here. And there's even a brand new IDE connector with no cable on it plugged in to the data/power connector. How about that? So we got our character ROM here, some just general purpose logic. This is a very small TMS 4036. That's a very small SRAM. It's something like 32 or 64 by 8 bits, I think. And this buffers one column of characters. And then you got the F8 CPU here, I do believe, and then it's got a, let me get closer so I can read it. There is a MK3850, that's the CPU, a 3861, this is a weird F8 bus to Intel style bus translator chip, two 1K by 4-bit 2114 SRAMs, some 4053s it looks like, an EEPROM which I believe is 2716, and then two other parts, MK3854 and a 3852, and these are like I/O ports, and one has a timer, I believe, going by the other one. Then on the glass driver board that's hooked directly to that display glass, and here's that other driver board, we got ourselves a 4514, that's a 1 of 16 CMOS selector, two high voltage 6-channel or 7-channel NPN transistor arrays, just some glue logic like AND gates, 6 of those 7 output high voltage shift registers, and these drive the rows. And then this selector drives the columns, and then there's this connection that goes on the side here that connects to the column circuitry right here. So what's really neat about this is this glass itself is like a set of very long decatrons, if you know what a decatron is. It is a neon-filled tube that can actually count, and it does this by the glow moves across. So what they've done is it's kind of like a stepper motor, a neon-filled stepper motor, and they send it a multi-phase drive signal which steps it to each column one at a time all the way to the end. And when it gets to the end, then there's a reset signal that starts to glow back up on the left side, and then it shifts down again. And that's how it works. So let's try to get this thing to operate. So right now what I see is it has this connector here, so I'm pretty sure the power supply here plugs in there. It's keyed, so it only goes in one way. There, like that. So now the power supply is plugged in. Then I'm going to have to get out the multimeter and trace out how this power supply works. I assume it takes 12 volts on this connector here. And then it has those two regulators, which I believe are 7825 footprint. I was going to measure that. Then your connection to the computer or whatever is through this parallel signal. So I'm sure there's like a 6 or 7-bit character, and then there's a signal you pulse to make it display it, and that's how it works. It's very simple. It's about the same level of difficulty as one of those HD 44780 LCD displays, i.e. not very. Just about anybody can probably get this to work. And it has the high voltage inverter on here, so that means you don't have to deal with the nasty high voltage. So we're gonna hook it up and see what happens. Oh hey, that'll shortcut things. There's actually markings. So the voltage is negative 20 volts, positive 20 volts, plus 10 volts, plus 12 volts. So yeah, getting this to work is probably not going to be terribly difficult with all these little clues to help. So we'll fluke this out, and I'll hook it up to my power supply and see what happens when I turn it on. Make sure we're in view here. So here's the main board. I know from experience, if this is like the other boards, this driver board will take negative 12 volts negative 250 volts and then 5 volts. So that's the power that runs this board. Checking where that 250 volts goes is fairly easy. It goes to all of these. There's some 910 ohm resistors on the board that do that run right to the glass, and they just hook right up to it, so that can help. And there's also the thing I find very hilarious, this CMOS chip, this 4514, it actually runs on about 10 volts, but its ground rail is sitting at negative 250 volts. So the ground pin on this CMOS chip is sitting at negative 250 volts, if you can believe that. So what I'll do, I'll unplug this display and then plug in this dead board here so it sits like that. So now what I'll do, I'll trace the ground side of this CMOS chip with my brand new Hamfest special multimeter here in continuity mode. And theoretically, it should run to this module here. So V out is right here, it says. Minus is right here. So that theoretically should go to the ground of the... And it doesn't. That's interesting. Does it go anywhere on this board? Kind of need one of these boards without the glass on it. Well, that's interesting. There's a little fuse there, and that fuse is connected to the high voltage. That's where that's like 3 ohms right there. It's a 2.7 ohm resistor right inside the fuse. That's kind of interesting. Right here in the fuse is a resistor. So it looks like this connector, it takes plus 10 volts, plus 20 volts, and minus 20 volts, and then ground, according to this. And then plus 10 volts is running to this big 7805 footprint. And then 5 volts comes out of there and runs to the 7409 by the looks of it. So this should be 5 volts right here. It is. I'm not sure why there are two 7805. Oh, this one's connected to... Oh, this is connected to 20 volts. This other regulator. And then the other side of that probably connects to this module, doesn't it? Which would be brown. Okay. So this is a 7805, and this is a 7812. So what I can do on this module is I can run this on 5 volts, bypassing this regulator, 12 volts, bypassing this regulator, and negative 20 volts using this regulator. The only thing I'm unsure of is what this transistor is doing. It's a JE1100. It's a big old BJT of some kind, I believe. I don't know what exactly it's doing. Oh, I bet that turns the high voltage brick on and off, probably. So let's see if it's in the ground leg of that high voltage brick. Yep, connects to the collector. And then this should be, this is ground, I believe. Or is this, oh, this, I know this is ground. Yeah. Okay, so this transistor here turns that high voltage brick on and off. So this signal runs somewhere. Oh, it connects to a 150 ohm resistor, which is connected to 5 volts, and the output of this 7409, I bet. Yep. Yeah, they got like a little weird little circuit on here to turn this transistor on, to turn our high voltage on. Not quite sure what's up with that. I may have to hot wire that to make the display light up. We'll see. So in any event, it looks like I need 5 volts, 12 volts, and minus 20. Unfortunately, my power supply can provide all of those voltages at one time. So now the next thing I'm going to do, just to make sure I have the correct connector, I'm 99% sure I do, but I am going to test. So we know 5 volts should be on pin 14 of that 7409, so I'm going to try some other pins here on these other chips to make sure that they're hooked up right. And I'm not getting anything, actually. I wonder if this connector's backwards. I guess it's possible. Let's see, I'll flip it around. It is keyed, but there is no pin in the cable. So we'll see if flipping this around will fix anything. I doubt if it will, but you never know. So try 5 volts again. I'm getting 560 ohms. Ground is working, I think. Yes, I do have... Ground is working now. Oh, it is connected now. Maybe the connector was dirty. So I'm getting 5 volts. I'm getting ground. So that's very important. I wanted to make sure I had 5 volts in ground before I fire anything up. This way I don't blow anything up. See if that cable was plugged in wrong too. It was turned around. That was not right. So if I had plugged this in, it would have blown up. So that is why I test this stuff, because you just never know. And it's very easy checking 5 volts in ground because it's always in the same place on the chips. So the next step is, get all the stuff out of the way. The next step is to add some power to this. And what I'm going to do, I am going to add some resistors on here, just some resistor leads poking up, so I can clip my clip leads on. That's like the cheap and dirty way. Resistors. So I'll choose 100K is probably good. Tin the leads of the resistors first. And that way they'll stick well when I go to attach them. Now I'm going to attach it here. This is, ow, negative 20 volts here, and then ground. So that'll make life easy. Oops. You don't drop the solder. Negative 20 goes there. Ground goes there. So now I got a cheap and dirty way to connect negative 20 and ground, and then I'll connect 12 volts here and 5 volts to this tab here, and we should be ready to rock and roll. Another thing, one of my pet peeves is clip leads. Clip leads are awesome when they work, but unfortunately these clip leads, when I bought them, the wire was so small and the resistance was so high that they just did not work worth a damn. So I have replaced this wire, and that's helped quite a bit. I need to get some proper job clip lead to banana plugs, or maybe even make them. So now what I've done is I've pulled back the boot on this one because this is ground, and I'm going to hook multiple things up to it. So what I'll do, I'll flip this display over in case it does anything interesting. Make sure that's in frame. It is, because we should be seeing stuff here. If this works, we should probably see a cursor appear if this works like the other one of these I've had. So we'll get some 5 volts going here. Right here. I do believe that's 5 volts. And just because that I said about testing, we'll make sure we've got power from the 5 volt all the way to the chip. And we do. So that's telling me my 5 volts is hooked up properly, and just for fun we can try that ground. And it is. So that means when I fire this up, it should work, or at least it's going to get power, and it should not blow up because I have tested it literally 3 times now. So now I need to get more clip leads because we've got 2 more voltages to connect. Hook up output 2. Output 2 will be my positive 12 volts. Let's see if I got a nice beefy clip lead for that. Oh yeah, this is one I've replaced the wire on. So this will be our 12 volts, which hooks up, I believe, let's see here. Let me fluke this out just to make sure I'm not going to blow it up. That's interesting. It's shorted. Oh, someone has added a wire on there, have they? They shorted the input to the output. That's interesting. I was wondering what that wire did. Well, I guess now I know. At least that's what it looks like they've done. What's weird is there's no longer a ground on this. I don't like that. In any event, it goes here, so I know that that's right. Well, what I can do, since I'm curious, I will look up the Fairchild F8 CPU pinout and see where it takes 12 volts at, because that device does take 12 volts. So the F8 on this board, it says, takes 5 volts and 12 volts. What I'll do is I will connect, and this is the CPU here, so I will poke this, and it says pin 3 is 5 volts. So pin 3 is here, so that connects to 5 volts. It does. Pin 4 is the 12 volts. And it connects to 12 volts. And then ground is pin 24, so that would be 21, 2, 3, 4. And it does. So that means when I plug this in, the chip should not have a problem. It should fire right up, hopefully. So that means 12 volts does indeed connect here. Looks like they have cut the ground and connected it to 12 volts and then disconnected the other for some unknown reason. Hopefully this thing still works. Yeah, 0 ohms between our 12 volts and 12 volt in. Move that clip lead over like that. Get this in frame, and then continue on. So the next step, I need negative 20 volts. So I have this ancient clip lead here. So I'll connect U to ground. So the positive side of that output on my bench supply is going to ground, and then the negative side, once I get another good clip lead here, will connect to that negative 20 input, which is right here on the other side of this resistor. So now after all that, we should have enough juice to fire this up if it's going to work. First things first, I have to set the power supply up. So output 1 will be 20 volts. I can just type it in. It's volt set 20. Enter. And current, I'll set it at 400 mils. It probably isn't going to take that much. Output 2, that is 12 volts. Set U to 12, and the current will be much less than that. I'll set to 400 mils also. Current set 0.4 enter. And then output 3, this is our 5 volts. And I'll set this to say 2 amps because it's probably going to draw quite a bit. And we'll set that to 5 volts. And hit the button. And well, yeah, a little too much load on there, so let's bump that up to 3 amps. Oh yeah, we're getting 800 mils on 5. Oh, we're maxing out 12. Oh, what's that? Hey, look at that. It's working, somewhat. Oh, yes it is working. It's working perfectly. When I look at it from the side, I can see the alternate rows are being lit. I'll zoom in on that now that it works. So how's that? It worked perfectly the first time. Not bad. I think I am going to turn this off. There we go, and you can see the thing I was seeing. But when the camera is head on to the display, you actually can't see that. So let's see if I can get the camera to stay up that way, up there. So now that the display is actually functioning like it should, you can see a couple things. So the way these self-scan displays work, like I said earlier, they scan left to right, and there's a signal that resets the glow back to the left. And you can see it's a little bit of glowing in here. This is the keep alive. So this gives us a couple ions over here, so when that reset occurs, the glow will snap back preferentially to this first column, and then every time it's pulsed, it will shift by itself one column over. And that's why you can see this dim glow, is because that is the scanning glow that goes across. And normally, if you look, like I said, head on, you cannot see that glow, because it's masked by the glass in the front. They have like some black lines, so you can't see that. And that's basically how it works. So now what I'm going to do, now that all that's functional, I will try and figure out what causes it to write characters on the glass. And I'll do that by taking another clip lead, hooking it up to my overloaded ground connection, and then put a resistor on it. Say 270 ohms, and then I'll just start probing the pins on that connector that are the data signals. And what'll happen when I poke the right one, it should advance the character position. Oh yeah, it does. And just like the other version of this display, when I write characters, I notice the display like glitches out while it writes them on there. Oh, that's interesting. My current limiting is hitting on my power supply. Well, that looks pretty awesome. I like how it's blinking too. So that's code FF or 7F, depending on how many bits this is. No, there's no clear signal, so you just basically mindlessly write characters into it. If it's like the other displays, the character codes like 0, 1, and 2 do things like clear the display out. So that thing's drawing quite a bit of current. It's drawing a little over an amp. It's kind of hard to tell. It's drawing about 1.3 amps when all of those dots are on. So I think that looks pretty sexy. I'll cycle the power here, that'll clear the display out. And then what I'll do is I'll get another clip lead going here on my vastly overloaded clip lead array and get another resistor. What I'll do is I will poke one of these other signals while I hit that signal that writes the data to the display and see what happens. Which signal writes? Oh, it's this signal, okay. Let's see if it'll write a different character for me. Oh, that's funny. That thing is bright. I'm sure you can hear it too, the noise it's making as it refreshes. There we go. And that thing is really drawing some current now. Nope. Oh well, in any event, I'll play with it some more, but I'm sure I can get it to work properly. I just have to hook a microcontroller up to it to poke those signals properly. So I hope you enjoyed that, and that was a real time of me getting this display to work. Yeah, glass is getting a little warm. So I had never used this before. I just took it out of the box, plugged it in, figured out how the power hooked up, and starting to do the signal poking around just to see how it works. So hope you enjoyed it, and I may do a follow-up video on my self-scan display technology because I have a whole bunch of these and I've gotten them all to work. And I hope you enjoyed it, and thanks for watching.